Hi guys, this is notes for chapter 7.3, which is similar triangles. Let's first start with the postulate about angle-angle similarity. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. And we can see that in the diagram to the right. So let's look at example 1. Okay? Determine whether the triangles are similar. If so, write a similarity statement. Explain your reasoning. So let's look at A. So since the measure of angle L is equal to the measure of angle M, that means angle L is congruent to angle M. Okay, so these two are the same. By the theorem we learned previously, we know that we can add up all the angles and they should equal 180. So let's go ahead and do that. 48 plus 57 plus x equals 180. So what we're doing is finding the missing part in each one. And 57 plus 75 plus y is equal to 180. Well, in the first one, if we subtract 48 and 57 from 180, we get x is equal to 75. Similarly, if we subtract 57 and 75 from 180, we are going to get y is equal to 48. So that means we now have 48 and 75. Okay? So now we have another angle that's similar, and that is the angles of 75 right here. So since angle L is congruent to angle M, so angle L is congruent to angle M, and angle K is congruent to angle P, that means the triangles are similar. So let's look at B. Angle RSX, so this angle, is congruent to WST, this angle, by the vertical angle theorem. Since RX is parallel to TW, that means angle R and angle W are congruent. So that means that they are similar by the AA similarity. So we have angle R is congruent to angle W, and angle RSX is congruent to angle TSW. Angle TSW. Okay, so that means they are both similar. So check, they were both similar. Let's go ahead and read these theorems down here. So we have the side similarity. If the corresponding side lengths of two triangles are proportional, then the triangles are similar. Side angle side similarity. If the lengths of two sides of one triangle are proportional to the lengths of two corresponding sides of another triangle, and the included angles are congruent, then the triangles are similar. So let's go ahead and apply this to example 2. So example 2 says, determine whether the triangles are similar. If so, write a similarity statement. So first, we're going to do the proportion for PR. So PR over SR. Well, PR is 8 and SR is 20. So that proportion is going to be 2/5. Okay? Now let's do the proportion for PQ over ST. So that's going to be PQ is 6, ST is 15, so this is 2/5. Now let's do QR over TR. So we get 5 over 12.5, which is 50 over 125, which is 2/5. So that means these are similar by the SSS theorem. So yes, by SSS theorem, because look, each of them gave us 2/5. Now let's do B. So we know that angle A is equal to angle A because it's part of the small triangle and the big triangle. So angle A is congruent to angle A. Now let's find the proportions. So AF over AB is equal to 10 over 10 plus 5, which is 10/15, which is 2/3. Now let's do AE over AC, which is 8 over 8 plus 4, which is 8 over 12, which is 2/3. Since the length of the sides that include angle A are proportional, that means these two triangles are similar based off of SAS theorem. So yes, by SAS theorem. Good, so we just did A and B. Let's go ahead and look at example 3. In the figure, angle ADB is a right angle. Which of the following would not be sufficient to prove that triangle A is similar to triangle BDC? Sorry, excuse me. So we are given that angle ADB is a right angle, and we need to identify whether or not they are similar. Since angle ADB is a right angle, angle BDC is also a right angle. Okay? Since all right angles are congruent, we can say that angle ADB is congruent to angle BDC. Okay? Now let's look through each of our choices. If AD, so we're looking at A right now, if AD over BD is equal to BD over CD, and these angles are congruent, then we can say that they are similar using SAS. So A works due to SAS. Let's check B. Now we're on B. If AB over BC is equal to BD over CD, and the angles that we talked about are congruent, then we cannot conclude that the triangles are similar because the included angle of side AB and BD is not angle ADB. So based off of this, we can right away say that the answer is B. So this was not true. This was not true because we can't make the conclusion since the angle of side AB and BD are not in the angle ADB. So that means our answer for the entire problem is B. So A works, C works, and D works. Okay. Let's go ahead and look at our next theorem. We have properties of similarity. So we have the reflexive property that says that a triangle ABC is similar to itself. Symmetric property says if triangle ABC is similar to triangle DEF, then the reverse is also possible. And then transitive property that says if triangle A is similar to triangle D and triangle D is similar to triangle X, that means triangle A is similar to triangle X. So let's do example 4, okay, which says find BE and AD. So since BE is parallel to CD, angle ABE is congruent to angle BCD. and angle AEB is congruent to angle EDC because they are corresponding angles. By AA similarity, triangle ABE is congruent to triangle ACD. So these triangles are congruent by AA similarity. So then we can start writing our proportions. So AB over AC is equal to BE over CD. Well, AB is 3, AC is 5, we don't know BE, and CD is 3.5. So if we cross multiply, we have 3 times 3.5 is equal to 5 times x. So then we have 9.15 is equal to 5x. Divide by 5, we have x is equal to 2.1. Okay? And since BE is x, this implies that 2.1 is equal to BE. Okay? Now let's do AC over AB is equal to AD over AE. Well, AC is 5, AB is 3, AD is y plus 3, and AE is y. So cross multiply, we have 5 times y is equal to 3 times y plus 3. If I distribute that 3, I have 5y is equal to 3y plus 9. Subtract 3y, I get 2y is equal to 9. Divide by 2, I get y is equal to 4.5. Okay, since AD is y plus 3, so AD is equal to y plus 3, so it's going to be 4.5 plus 3, which is 7.5. Okay, let's go ahead and look at the next example. Example 5 says Haley is estimating the height of the Cyclone roller coaster in Galveston, Texas. She is 5'3" tall and her shadow is 3 feet long. If the length of the shadow of the roller coaster is 34 feet, how tall is the roller coaster? So here is shown the sketch. Okay? So we need to put a proportion up in order to solve this. So we have Haley's height, which I'm just going to say like this, over the coaster's height is equal to Haley's shadow over the coaster's shadow. I know I'm going over this, I apologize. So Haley's height is 5.25, coaster's height we don't know. Haley's shadow is 3, coaster's shadow is 34. So if we cross multiply, we have 5.25 times 34 is equal to 3 times x. 5.25 times 34 is 178.5 equal to 3x. If we divide both sides by 3, we have x is equal to 59.5, which is going to be the height of the roller coaster. So the coaster is 59.5 feet tall. Okay. Now let's look at this last concept, and then that will conclude 7.3. So we have triangle similarity. So we have the AA similarity, which means, remember, if we have two angles that are similar. We had the SS similarity, which means that if all sides are proportional. And then we'll have the side angle side similarity, where two sides proportional and the inner angle is congruent. So that's what we learned today. So that concludes the notes for 7.3.